Hi everyone, let's begin with revealed preferences today. In chapter 6, we saw how we can use information about the consumer's preference and budget constraint to determine his or her demand. In this chapter, we reverse the process and show how we can use information about the consumer's demand to discover information about his or her preferences. Up until now, we were thinking about what preferences could tell us about people's behavior, but in real life, preferences are not directly observable. We have to discover people's preferences from observing their behavior. In this chapter, we'll develop some tools to do this. When we talk of determining people's preferences from observing their behavior, we have to assume that the preferences will remain unchanged when we observe the behavior over very long time spans. This is not only not very reasonable, but for the monthly or quarterly time spans that economists usually deal with, it seems unlikely that a particular consumer's tastes would change radically. Thus, we will adopt a maintained hypothesis that the consumer's preferences are stable over the period of time for which we observe his or her choice behavior. This was majorly just the introduction of what we are about to do. Let's try to read into what actually we're going to study, the idea of revealed preferences. Before we begin this investigation, let's adopt the convention that in this chapter the underlying preferences, whatever they may be, are known to be strictly convex. Okay, we're going to assume that whatever we're going to assume that whatever our preferences are just are convex in nature. Thus, there will be a unique demanded bundle at each budget. This assumption is not necessary for the theory of revealed preference, but the exposition will be simpler with it. So what are we doing here? We are assuming that the preferences are strictly convex, and there will be unique demanded bundle at each budget. Okay, this assumption is not necessary for the theory of revealed preference, but the exposition will be simpler this way. Consider figure 7.1, where we have depicted a consumer's demand bundle and another arbitrary bundle y1 y2 that is beneath the consumer's budget line. We know that this is the consumer's budget line, and this is the bundle that we're assuming x1 x2 that the consumer has demanded, and this is another arbitrary bundle. Arbitrary bundle is just some bundle that is beneath the consumer's budget line, because the budget line is here, this is below that budget line. Suppose that we are willing to postulate that the consumer is an optimizing consumer of the sort we've been studying. What can we say about the consumer's preferences between these two bundles of goods? Well, the bundle y1 y2 is certainly an affordable purchase at the given budget. The consumer would have bought it if he or she wanted to, and would even have had money left, because they're buying something which is inside of the budget line and not on it. They have the money, they have some money to spare still from their budget. Since x1 x2 is an optimal bundle, but what is x1 x2? It's an optimal bundle. Okay, it must be better than anything else that the consumer could afford. So if you take any xyz point here, there, anywhere, if you take an xyz point, let's say this point or this point, any point, this point x1 x2 is always going to be better than any other point, because this is the optimal bundle. Okay, hence in particular it must be better than y1 y2. Hence y1 y2 is any arbitrary bundle like these 2 points that I've made here. So it is going to be x1 x2 is going to be better than a y1 y2 as well. The same argument holds for a bundle or on or underneath the budget line other than the demanded bundle, since it could have been bought at the given budget but wasn't. Then what was bought must be better. Here is where we use the assumption that there's a uniquely demanded bundle for each budget. If preferences are not strictly convex, so that indifference curves have flat spots, it may be that some bundles that are on the budget line might be just as good as the demanded bundle. So if preferences were not convex, since we've assumed that they are convex, but let's say if they were not strictly convex, indifference curves have flat spots. Okay, so indifference curve would have flat spots. It may be that some bundles that are on the budget line might be just as good as the demanded bundle. This complication can be handled without too much difficulty, but it is easier to just assume it away. So it is easy to work around this, but for now we have assumed that uh, they are convex, so let's just let that be for now. In figure 7.1, all of the bundles in the shaded area underneath the budget line are revealed worse than the demanded bundle x1, x2. This is because they could have been chosen but were rejected in favor of x1, x2, right? We will now translate this geometrical discussion of revealed preferences into algebra. So we will now try to understand the math behind this. Let x1, x2 be the bundle purchased at price p1, p2 when the consumer has income m. So we are assuming that this is the bundle. Of course, we've assumed this. Let's assume that the prices are p1, p2 when the consumer has income m. Okay, so we know how to make a budget equation. What does it imply to say that y1, y2 is affordable at those prices and income? It simply means that y1, y2 satisfies the budget constraint. This is the budget constraint and it's satisfying it, which means that y1, y2 is affordable at those prices. Since x1, x2 is the actual budget, it's the actual constraint that you had bought, demand bundle that you had bought, it must satisfy the budget constraint with equality. Now this is going to satisfy it with equality since it was actually bought. Putting these two equations together, the fact that y1, y2 is affordable at the price at the budget p1, p2 m, which is price of the first, price of the second, and the income, means that p1 x1 plus p2 x2 is greater than equal to, okay, because y1, y2 is affordable and x1, x2 is actually bought at that, so it has to be put in this way, is affordable at the budget. Okay, because we're putting m equals to this, so in place of m in equation 1, let's say we're going to put this, and you see the sign is reversed because the place of both of these are reversed as well. If the above inequality is satisfied and y1, y2 is actually a different bundle from x1, x2, we said that y1, y2 is directly revealed preferred to x1, x2. Now it has to be that y1, y2 is different from x1, x2, then only we can say that it's directly revealed preferred to y1, y2. What? x1, x2. We know that the left hand side of this inequality is the expenditure on the budget that is actually chosen at the price. Okay, so left hand side, which is this one, is the actual expenditure which you've chosen at the actual which you which is the expenditure that you've undertaken because of the actually chosen budget bundle at prices p1, p2. Thus, revealed preference is a relation that holds between the bundle that is actually demanded at some budget and the bundle that could have been demanded at that budget. Okay, so what is revealed preference? Is the budget is revealed preference is a relationship that holds between the bundle that is actually demanded at some budget and the bundles that could have been demanded at the said budget. The term revealed preference is actually a bit misleading. It does not inherently have anything to do with preferences, although we've seen above that if the consumer is making optimal choices, the two ideas are closely related. Saying X is revealed preferred to Y, it would be better to say X is chosen over Y. When we say that X is revealed preferred to Y, all we are claiming is that X is chosen when Y could have been chosen. That is the said equation. Okay, so X is chosen when Y could have been chosen. Okay, because this is the constraint. From revealed preference to preference, we can summarize the above section very simply. It follows from a model of consumer behavior that people are choosing the best things they can afford. that the prices they make are preferred to the choices that they could have made. Okay, or in the terminology of the last section, if x1 x2 is directly revealed preferred to y1 y2, then x1 x2 is in fact preferred to y1 y2. Let us state this principle more formally. Let x1 x2 be the bundle chosen when prices are this, and let y1 y2 be some other bundle chosen, bundle such that this is true. Then if the consumer is choosing the most preferred bundle she can afford, we must have x1 x2 revealed preferred to y1 y2. When you first encounter this principle, it may seem circular. If x is revealed preferred to y, doesn't that automatically mean that x is preferred to y? The answer is no. Revealed preferred just means that x was chosen when y was affordable. Preference means that consumer ranks x ahead of y. Now this is important, okay? So it does not mean that it was preferred to y, it just means that x was chosen when y was still affordable. Okay, preference on the other hand would mean that the consumer is ranking x ahead of y. If the consumer chooses the best bundle she can afford, then revealed preference implies preference, but that is the consequence of the model of behavior, not the definition of the terms. Okay, so if the consumer chooses the best bundle she can afford, right, like x, then revealed preference implies preference. Okay, but that is the consequence. Yeah, so this is why it would be better to say that one bundle is chosen over another as suggested above. So this is why it would be better to say that one bundle is chosen over another. Okay, then we would state the principle of revealed preference by saying if a bundle x is chosen over a bundle y, then y must be preferred to then x must be preferred to y. So if a bundle x is chosen over bundle y, so if you're choosing a bundle x over another bundle y, then x must be preferred to y. So you're preferring x over y. In this statement, it is clear how the model of behavior allows us to use the observed choices to infer something about the underlying preference. Okay. Whatever terminology used, the essential point is clear. If we observe that one bundle is chosen when the other is affordable, then we must have learned something about the preference between the two bundles, namely that the first is preferred to the second. So we're basically knowing that the preference is clear now. Now suppose that we happen to know that y1 y2 is a demand bundle at price q1 q2, and that y1 y2 is itself revealed preferred to some other bundle z1 z2. Then you basically take this very equation but put y instead of x and z instead of y. Then we know that x1 x2 is preferred to y1 y2, and y1 y2 is preferred to z1 z2. The transitivity assumption, from the transitivity assumption we can conclude that this is true from transitivity. This argument is illustrated in figure 7.2, which we will see ahead. Revealed preference and transitivity tells us that x1 x2 must be better than z1 z2 for the consumer who made the illustrated choice. It is natural to say that in this case x1 x2 is identity revealed preferred to z1 z2. Of course, the chain of observed choices may be longer than just 3. If bundle A is revealed preferred to B, and B to C, C to D, all the way to M, say, then bundle A is still indirectly revealed preferred to M because of the transitivity assumption. The chain of direct comparisons can be of any length. If a bundle is either directly or indirectly revealed preferred to another bundle, we will say that the first bundle is revealed preferred to the second. The idea of revealed preference is simple, but it is surprisingly powerful. Just looking at a consumer's choices can give us a lot of information about the underlying preferences. Consider, for example, figure 7.2. Here we have several observations on demand bundles at different budgets. We can conclude that from these observations that since x1 x2 is revealed preferred either directly or indirectly to all the bundles in the shaded area, so any bundle, let's say here, anywhere, if it's revealed preferred, if x is revealed preferred, x1 x2, either directly or indirectly to all the bundles in the shaded area, X1, X2 is in fact preferred to those bundles by the consumer who made these choices. Another way to say this is to note that the true indifference curves through X1, X2, whatever it is, must lie above the shaded region. Okay, so it should be something like this. Okay, yeah. Let me just try to construct an indifference curve that we're trying to. Oh my god, sorry. Okay, so it should be something like this. Yep. Okay, this is going to be the indifference curve in that case. Now, what we were trying to study before, and I kind of lost a way to that, is um, we we read that X1, X2 must be better than Z1, Z2 for the consumer who made the choice, because we know that X1, X2 is better than Y1, Y2, and Y1, Y2 is better than Z1, Z2. Okay, so here if you look at this, let's just remove this. Yeah, so we know from this area alone, just this area, this budget line, basically this budget line is what we're talking about at the moment. um, let's just look here. So we know that X1, X2 is preferred to Y1, Y2 because it is lying on the very budget line. Okay, so in this case this one ranks higher. Okay, let's talk about the other budget line. Oh my god, what am I trying to draw really? Okay, let's talk about this one. So you know that since y1 y2 this time is on the budget line, it's going to be preferred to z1 z2. Okay, but we know from the first one that we prefer x1 x2 to y1 y2, and hence by transitivity we can say that x1 x2 is revealed preferred to Z1, Z2. That's what it says. The bundle X1, X2 is indirectly revealed preferred. Why indirectly? Because directly Y1, Y2 is revealed, X1, X2 is revealed preferred to Y1, Y2, and Y1, Y2 is revealed preferred to X1, X2. But by the transitivity assumption, which is by indirect methodology, we can say that X1, X2 is basically revealed preferred to Z1, Z2. Recovering preferences. By observing choices made by the consumer, we can learn that his or her preferences. We can learn about his or her preferences as we observe more and more choices. We can get a better and better estimate of what the consumer's preferences are like. Yeah. Such information about the preferences can be very important in making policy decisions. Most economic policy involves trading off some goods or others. If we put a tax on shoes and subsidize clothing, we'll probably end up having more clothes and fewer shoes, right? So we put a tax on shoes. So you're saying that whatever shoes you produce, we're putting taxes on them, and we're subsidizing clothes. So how so many clothes you produce, we're going to give you money in return for that. Okay, so we'll have more clothes and fewer shoes. In order to evaluate the desirability of such a policy, it is important to have some idea of what consumer choice preferences between clothes and shoes look like. So we have to know what the people want, and what their preferences are when it comes to clothes and shoes, right? So by examining consumer choices, we can extract some information through the use of revealed preferences and related techniques. If we are willing to add more assumption about the consumer preferences, we can get more precise estimates about the shape of indifference curves. For example, suppose we observe two bundles y and z that are revealed preferred to x. Okay, let's look at 7.3. So y and z are on the two budget lines respectively, which are over the X bundle, so they are both revealed preferred to X, and that we are willing to postulate preferences are convex, then we know that all of the weighted averages of Y and Z are preferred to X as well, right? This is already studied. If we are willing to assume that preferences are monotonic, then all the bundles that have more of both goods than X, Y, Z, or any of their weighted averages are also preferred to X. If we have bundles that have more of uh, both goods than X, Y, and Z, then of course those bundles are also going to be better than X or preferred to X. The region labeled worse bundles, which is this one, all the blue shaded area, consists of all the bundles to which X is revealed preferred. Now X is going to be revealed preferred to all of these bundles, am I right? That is, this region consists of all the bundles that cost less than X, along with all the bundles that cost less than X, and so on. Okay, so there is some bundle, let's say this one, that costs low than less than X, and there's this bundle that costs less than the one that costs less than X. Okay, and so on. Thus, in figure 7.3, we can conclude that all of the bundles in the upper shaded area are better than X, and that all the bundles in the lower shaded area are worse than X, according to the preferences of the consumer who made the choices, of course. So, this is going to be all the bundles that are better than X because they are higher than X. Okay. According to the true indifference curve through X must lie somewhere between the two shaded sets. We've managed to trap the indifference curve quite tightly, simply by an intelligent application of the idea of revealed preference and a few simple assumptions about preferences. So we see that it has to be the indifference curve, which is the curve at which we'll be indifferent, is going to lie somewhere in between the better and the worse bundles, right? So that's it. A weak axiom of revealed preference. All of the above relies on the assumption that the consumer has preferences and that she is always choosing the best bundle of goods she can afford. If the consumer is not behaving this way, the estimates of the indifference curves that we constructed above have no meaning. So if the very consumer that we are talking about is not choosing the best bundle of goods she can afford, then all of this uh, estimates of indifference curve have no meaning. Okay, the question naturally arises: how can we tell if the consumer is following the maximizing model? We're assuming it, but how can we tell if they are maximizing uh, their preferences? Or to turn it around, what kind of observation would lead us to conclude that the consumer was not maximizing? Okay, so vice versa. If that's true as well, then we can conclude something about the consumer not using the maximizing model. Consider the situation illustrated in 7.4. Could both of these choices be generated by a maximizing consumer? According to the logic of revealed preferences, figure 7.4 allows us to conclude two things. One, x1, x2 is preferred to y1, y2. Now, we've already gone over this because it's on the budget line or to the right of y. And y1, y2 is preferred to x1, x2. Now, if you look at this budget line, y1 y2 is lying on this budget line, so x1 x2 is actually at the left of it, or basically inside the budget uh, line. Okay, so y1 y2 is going to be preferred to this. Okay, in figure 7.4, the consumer has apparently chosen x1 x2 when she could have chosen y1 y2, indicating that x1 x2 was preferred to y1 y2, but then she chooses y1 y2 when she could have chosen x1 x2, indicating the opposite. So we're basically in a conundrum here. Okay, this is clearly absurd. Clearly, this consumer cannot be maximizing consumer. Either the consumer is not choosing the best bundle she can afford, or there is some other aspect of the choice problem that has changed that we have not observed. So this is something that the consumer is doing, or there's something wrong with the consumer's maximizing model, because of which she's not choosing the best bundle she can afford. Perhaps the consumer's tastes or some other aspect of our economic environment have changed. In any event, a violation of this sort is not consistent with the model of consumer choice in an unchanged environment. The theory of consumer choice implies that such observations will not occur. If the consumers are choosing the best things they can afford, then things that are affordable but not chosen must be worse than what is chosen. If the consumer is choosing the best thing they can afford, then things that are affordable but not chosen, if there's something that's still affordable but it's not chosen, must be worse than what is chosen. So it has to be the case. Economists have formulated this simple point in the following basic axiom of consumer theory, which is the weak axiom of revealed preference. If x1 x2 is directly revealed preferred to y1 y2, then the two bundles are not the same. Then it cannot happen that y1 y2 is directly revealed preferred to x1 x2. So the vice versa case basically cannot be true. Okay, you can't say that x1 x2 is directly revealed preferred to y1 y2 and y1 y2 is directly revealed preferred to x1 x2 when they're both not the same. In other words, if a bundle x1 x2 is purchased at price p1 p2 and a different bundle y1 y2 is purchased at price q1 q2, then if this is the case, okay, then this cannot be the case. Basically, you are again just bringing left hand side to the right and right to the left. In English, if the y bundle is affordable when the bundle is purchased, then when the y bundle is purchased, the x bundle must not be affordable. You cannot afford this bundle, which is why you're choosing y. Okay, that should be the case. You can underline this one. The consumer in figure 7.4 has violated warp, which is a weak axiom of revealed preference. Thus, we know that this consumer behavior could not have been a maximizing behavior. There is no set of indifference curves that can be drawn from 7.4 that would make both bundles maximizing bundles. There is no indifference curve that you can draw to make them both maximizing bundles. Here, it is possible to find indifference curve for which his behavior is optimal behavior. One possible choice is illustrated.